These are some applications of fractions that you might come across in your real life. So you have 28 out of 35 questions correct on an algebra exam. So 28 out of 35 we can write as a fraction. Your friend or classmate, I don't know if he's your friend or not, got 27 out of 45 correct on a different exam. 27 out of 45. So part A says, what fractional part of the exam did you and your classmate answer correctly? So you answered 28 out of 35, and your friend or classmate answered 27 out of 45. Now, which of you did better on the exam? Now we're going to have to do a little bit of comparison. So one way to do this is to simplify down to lowest terms. So looking at the first one, 28 out of 35, I know that I could write 28 as 4 times 7, and I could write 35 as 5 times 7, and those 7s will cancel, and so we got 4/5 correct on our test. Our friend, I could take this as 3 times 9, and this could be considered, I don't know what those are for, sorry. 45 would be 5 times 9, and my 9s will cancel, and so our friend only got 3/5 of his questions right, and so we did better. Us. Yay! So that's one way that you can compare, is to break things down into lowest terms. So notice what I had to do is I had to make that denominator the same so that I could compare. Otherwise, it's very difficult to do so. Here's another application question for you to try. So press pause, read the question, go through it in its entirety, and then press play to see if you agree with my answer. I have a bag of M&Ms, or a bag of M&Ms, and 14 out of 42 of those M&Ms are red. So this is my bag. Now, I can leave it as 14 over 42, but I can also reduce this. So if I wanted to reduce this, I would be looking for something that those two had in common. So it looks like they're both divisible by 7, and that would give me 2 on the top and 6 on the bottom. And it looks like I didn't quite come up with the correct greatest common factor, and I could still continue to divide this. So divide this by 2, which gives me 1 over 3. So a third of my bag of M&Ms are red, in a perfect world, but probably not really. Now my friend has one of those little mini bags of M&Ms, so too bad for her. There's only 12 M&Ms in the bag, so that's the total. That number has to go on the bottom because that represents the whole, and 4 of those are red, so 4 of 12 are red. So now if they want to compare what my friend had to my bag of M&Ms, I will have to reduce this to simplest terms. 4 divided by 4 is 1, and 12 divided by 4 is 3. And so if we're comparing fractions, even though she had much fewer M&Ms than I did, you can see that we have the exact same fraction of red M&Ms in our bags.